The paper title is Supervised Domain Adaptation from Syntax Recognition for License Plate Recognition. If you're ready, please start your presentation.
Okay, thank you very much for these occasions. Today I would like to present supervised domain adaptations from syntax recognitions for license plate recognitions. We are from the Faculty of Computer Science, Universitas Brawijaya from Indonesia. So the background is that we have so many vehicles, even getting condensed, about 148 million vehicles, and growing annually by 4.42%. And manual surveillance right now is unsustainable, or government started to apply CCTV from various locations. License plate recognition is key for the traffic law enforcement and automatic monitoring. So, for examples, helmet detections and surely license plate recognitions. However, the camera installations also various. So as you can see, it's quite challenging. There are various occlusions. There are various intensity, various blur rate, and various perspective, making the recognitions more challenging. Also, there are also various scales, also the resolutions, because we have so various quality of the camera. So that the challenges is that also getting worse because we have so many colors and so on. Also, it's quite hard to detect and recognize characters and numbers from arbitrary positions. So in that, the challenge in domain adaptations. So there are the domain differences, like fonts, layout, aspect ratios. For instance, if we would like to incorporate syntax versus license plate, and in the real world conditions, there are low light, motion blur, fog, occlusion, and so on. And also, it is hard and limited to manually label the training data. It requires high costs and times. The syntax recognition models not inherently structured for license plate recognitions, rigid formats. There are methods which are proposed by Liang in ICML 2020 called source hypothesis transfers, or short for unsupervised domain adaptations. That we could see here is just merely the freezing the classified layers. However, it's quite interesting is that classified layer is called hypothesis, which could preserve the distributions of the source data. We imagine this approach to be applied to the supervised manner in license plate recognitions. As we can see from this example, the source data has the similarity with the target data. Even they have the same class and number of the class, so it is possible to adapt this to the supervised manner. It's just merely froze the classified layer and tune the feature extractor layers. If we can see from the distributions, from the TSNE, the source only and the short, we could see that mostly the distributions of the data can be preserved by using the short methods. So, as you can see here, the circles in the dark colors denote unseen source data, and stars in the light denote the target data. The different colors represent different classes. So that the formulation of short is merely like this. There is the we can see this classification laws. We can use some kind of like cross entropy laws and or whatsoever. However, if we could see that the classifier part of the source and the target are shared and frozen, so which is called hypothesis during the adaptations. So that using this formulation during training, we would like to tackle the domain shift problems. The domain shift problems, such as differences in the font, layout, and aspect ratio, pose challenge when applying general syntax recognition models to license plates. Supervised domain adaptations address this by fine-tuning pre-trained SDR, syntax recognition baseline models on small label domain-specific datasets. So our work adopts this approach using the baseline CNN by SDM framework, which selectively freezing and updating components like a feature extractor, sequence modeler, and transformation layers. This strategy preserves generalization from a large-scale pre-training while improving adaptation to the structural characteristics of the Indonesian plates. Then, so that our strategies based on the short style adaptations, which I mentioned before. However, the case strategies is that we freeze the prediction, in this case, CTC layer, or you can freeze the classification layer. Second, fine-tune SCN by SDM TPS modules. We also use regularizations for preventing from overfittings. And the target preserve knowledge while specializing to the new domain. So as the source models, we use the baseline, which are model which compose of first spatial transformers, second CNN backbones, which you could choose either VGG or ResNet or CLIP. Third, we use the sequence modeling for capture the pattern of the sequence using by STM, and also CTC, which is the prediction, which is frozen during adaptations. So this is quite a baseline. The idea is simple, which the input image with the spatial transform, it transformed into the proper manner for recognitions, and then extracted using the CNN. It was trained on a large NG-SYN dataset, which consists of 8.9 million pair image and digitized characters and numbers, also syntax of 5.5 million. So in total, there is 14.4 million in total as a training data. So that we use a short for supervised domain adaptation versions. It could be easily adapted because the number of class is the same. There are alphabets and numbers. So the source the source model, already trained to the large syntax recognitions, which has the various characters of various perspective and of various scale and so on. And it should be rich information contained inside this model. So we would like to maximize and match the distribution of the source model by using short for supervised domain adaptation versions, which is just merely frozen these layers, and we start to adapt the backbone layers here to the license plates recognitions, which are different between unsupervised and supervised. That in the supervised, the labels of the target are different. So we adapted to the small data. In Indonesia, we have the national competitions called Satria Data in 2023, which is followed by the undergraduate students of all universities in Indonesia. And on that time, it contained 900 images. And our team that time passed to the final by using this approach. So the training is 700, the validation 100, and test 100. We use the 30,000 iterations with a basis of 8, and using ADA delta optimizers. We also try the click, so the click rate of 5 and maximum of sequence length is 25. So for latency, ResNet got 30 milliseconds and VGG 12 milliseconds. So for the evaluations, besides accuracy, we also use normalized edit distance, which merely counting the false recognitions. For instance, if this one character is false, the normalized edit distance value will decrease, such like that. So experimentally, we tried the various freeze and tune area, various freeze and tune layers. So we can see for the cross is the frozen layer, and this symbol is a tune layer. So we can imagine the position of the frozen layer by using this symbol. From that various positions of frozen layers, the result confirm our hypothesis that the predicting head should be frozen and keep the backbone layers to be tuned. It got the highest accuracy and highest normalized edit distance. So this is the example of the results. As you can see, the dataset actually challenging. For example, for these two images, we as human is still difficult to guess what the number is. Also, the machine is. However, for these three, the machine can properly guess the digitized numbers and characters, even though there's the difficulty of the blurry intensity and also perspectives. It doesn't require any bounding box. It's just directly guessed from the natural image. As the latency, we try on the Jetson KVL-X. The ResNet model ran roughly 30 milliseconds per image, about 30 frames per second. In conclusions, syntax recognition models can be adapted to the license plate recognitions with minimal data. By selectively freezing, especially prediction layer, we could get optimal adaptations. So, and spatial transformer plus CNN layer, for this case, ResNet is the best combo under supervised domain adaptations. So real-time inference on embedded hardware is feasible also. It's efficient deployable license plate recognitions under data scarce conditions. Thank you very much.